Okay. Go ahead and finish what you're working on, but I do want to, I guess I should turn on the lights for this. Couple of quick notes. I'm just going to extend the due date on this because I realize there was some confusion even though I went over this multiple times. I need y'all to pay attention. This is the review that I asked y'all to do with Quadratics. There is information down here about identifying the number sets that numbers fit into, but I need y'all to get this sheet out and I need you to look at the top. I need everyone to get this sheet out. DJ, this one's yours. So, it says Quadratics Unit Practice in the top right-hand corner. I need you to look at this sheet first. And so, the whole point of this is based on our test, we needed more practice with writing vertex and factored form when given certain details. We needed more practice in solving quadratic equations, especially because several of us wanted to do a retest, okay? But this is practice that all of us needed. All of this paragraph at the top is in reference to this skills practice that we had leading up to the test. Huh? What do you mean? I thought it was clear, but that's what I'm just going over right now. So it was the review for the quadratics test, right? That was the practice, and I could have just said that, and that's my bad. But it was the review for the quadratics test. The thing to notice is I only picked certain problems. If you notice, the very first thing it says is lesson 4, form of quadratics. That's not even until the second page, but lesson 4, forms of quadratics. And then I only asked you to do parts B, and then on the back side, part D. If I can get those pages to separate. B and D for that lesson 4, forms of quadratics. Jelani, you haven't even gotten this sheet of paper out, do you? Right, so B and D. I don't have you working on A and B at the bottom of that page whatsoever, because that's not going to help you as much as some other stuff. So, then I identify more problems that you have to do. All of it designed to help you review and be better at these skills so that you can do a retest, or even if you don't want to do a retest, to be better prepared. I have extra copies of this skills practice if you need it, but as a reminder, like, it is a decent bit of work if you haven't done any of it already, but you should have already done some of these problems. Hopefully at least like half of them you've already done. Since there was confusion on that side of things, because I didn't just put skills practice and that's my bad, I did show this to y'all last week before we got out, but I do know we forget things. I will allow you to turn this in on Friday, but we are still continuing with our learning. So I am taking some of the homework off just because we won't get to it, the homework that I showed you yesterday. Is there any confusion or any questions about this homework that we have due now on Friday? This sheet? Yeah. So notice all of this top section is in reference to this information. So you need to do this as well. This top is in reference to this. So like if you go to the second page, well, no, you have to turn this in as well. So there's that skills practice. But then like if you look at the second page here, it talks about lesson 4, forms of quadratic equations, part B. So you need to do all of these. And part D, so you need to do all of those. And so you have those mostly done. Now, it looks like you just stopped after finding A. Remember, the whole point is to write the equation. So you have the 2x intercepts. So now that you have A, you can write the equation for that. Flip, this is part, no, there's a third page. Yeah. Part C. Yeah. What number, page number is at the bottom? Page 25? Okay. So DJ is asking a good question just for clarification. Lesson 5. Part C. That is page, what, 25? Is that what it says in the bottom right-hand corner? So it continues on to that third page. Yes, sir. All right, we gotta get started with today. Gotta get moving. Which one? Skills practice or the what tells you what to do? Like this information? Other sheet? I'll have to print out a copy, I think, for you. I think I just gave that my last copy. I just gave it my last copy, so I'll make a copy for you hearing that. Okay, so let's get started with today. Yes, I need your graphic organizers out, ready to turn in, because today is definitely the day it is due. I will collect it after we go over the bell ringer. Maybe. I'll look in a second. So, I asked you to identify all domain intervals over which the function was increasing. I do want to point out, what notation should we always be using to indicate decreasing? Interval notation. That's the big thing. And I want you to notice that when we look at this graph, it starts out doing what? As I move from left to right, it is decreasing. How's a way, or what is one way that we know it's decreasing all the way through there? The tangent line, right? Notice if I draw a line tangent to that curve, the line has what kind of slope? The slope. Negative. Right? A negative slope means it's decreasing. That's the big thing to notice there. And then the x value where it starts decreasing is at negative infinity. So a lot of us are doing very well there. Comma, and it stops decreasing at the what? And what kind of point is that? A negative? For the x and for the y, yes. Come on, think about that point in terms of the graph.
The decimal. It's the minimum.
There we go. What kind of minimum? Is that an absolute minimum?
It's relative.
How do we know it's relative?
It's only for this graph.
Notice at this end it keeps going down, right? So is that the absolute lowest y value for the entire function? No. Right? So we want to notice it's only a relative minimum, but after it hits that minimum, it starts to increase. So we don't want that right now. And then where does it start decreasing again?
Oh, there, I can't see your hand. There you go.
But what kind of point is that? Again, the maximum, absolute or relative?
Relative.
Okay. And then where does it stop decreasing? Infinity, right? It never really stops decreasing. Okay. So looking at our responses, we seem to be pretty okay with the decreasing. That 16.9, I do want us to pay attention to that. Where is that 16.9 probably coming from? But the y. Remember, and that's why I use this language. Identify what kind of intervals? What are the only types of values that should go in the domain intervals? Yes. Remember, what you're telling me is what x values, where is that function decreasing? Right? I already know it's decreasing from 16.9 to negative infinity because it's decreasing. It's going from a large number to a small number. I need you to tell me where that's happening. But again, it's to a positive infinity because it's going to the right. So be wary of that. Be careful about that. Let's check for the increasing. So negative 2.097 to 1.431 is the most common. Should we have parentheses or brackets? Why? Okay, so a note that we should have made yesterday was that we can never equal it. Also remember, to be increasing, the slope of that tangent line has to be what? Positive. What is the slope right here though? So remember, that slope is 0, so it is neither increasing nor decreasing. That will not be included. And so notice it's starting from here, not the negative 5.049. We're not using the y. It's a domain interval. Negative 2.097 up to this x value of 1.431. I gave you those points. If I didn't give you the maximum and the minimum though, what could you have done? Menu, analyze graph, minimum, maximum, right? That's all you would have to do to be able to identify it. You do need to remember to identify those x values, and so analyze that graph. I will not give you those points in the future. You have to know how to do that. Okay? So what is the degree of the function? I saw degree 1. Most of us said degree 3, although only 9 of 13 of us responded. Guys, we got to answer bell ringer questions. Talk with your groups, right? I heard DJ and Grayson talking very effectively earlier about how to do increasing and decreasing, I think, right? Talking about the x values only. The bell ringer is a great time to learn from each other. This should not be one of those things where we sit there silently. Why is it degree 3? We have 3 factors, right? And so it's a degree 3. If I were to multiply this all the way out, what would be the highest power? 3. X to the 3rd, right? X cubed. And so that is something to notice. I didn't ask about it, but does anyone know the roots off the top of their head? Right? We should be able to identify it right away. You can also set it equal to 0 to figure it out. What's the multiplicity of each of these roots? 1. Which, if I add up all those multiplicities, it adds up to the degree of 3. Okay? What was the A? I hope that's something we all got. Negative 1? Well, in this case, negative 1, right? So notice it's not a 1, it is a negative 1. So one thing I want to point out about this is, we saw this already with quadratics. If it was 1 times x minus 3 times x plus 1, that concavity was what? The concavity though was, it was concave up, right? So what if it was negative 1 times x minus 3 times x plus 1? That'd be concave down. And so what we should notice is that negative, does anyone know an R word that would describe what it's doing?
Reciprocal.
Not a reciprocal. Say again? Not a replicate.
Reverse.
Think about a mirror.
Replica.
It's reflecting,
Like a mirror.
right? Notice that negative is reflecting it over the or the x-axis. And so I do want you to notice, because this is going to help you on today's lesson a little bit. Does anyone remember what y equals x cubed looked like? The shape. So it started in which quadrant? 1, 2, 3, and 4. It started in which quadrant? 3. It went through the origin and then it went into quadrant 1. There, that's what x cubed looks like. So if you notice right here, when there's a negative out in front, what quadrant is it starting in? quadrant 2, and it's ending in quadrant
4.
because it also vertically reflected, right? So this came up to here, came through, and came down. So it's not necessarily affecting concavity in this. I mean, it is affecting concavity, but not in the sense of the parabola concavity. But I want you to just notice that A is affecting which direction, and so you need to know those orders. And the same thing is with x to the 5th. Remember, x to the 5th just flattened out in the center, right? So what's going to happen with negative x to the 5th? Start in which quadrant? 2, and it's going to flatten out and then go into 4, right? So that negative is just affecting the end behavior. And that's the big thing I want you to notice, is that positive versus negative is affecting the end behavior. That's something we didn't spend a lot of time on, but it will help us with today's lesson. Oh, man. Y'all, last night I went to bed at 7:30. I was not feeling good. Still recovering. I don't know if it's the weather or just not getting enough sleep recently. Alright, so we already talked about the quadratics review. We're going to get back to that lesson 3 polywog, key characteristics of polynomials. We're going to end on this lesson 4. Please hear me very clearly, just sake of time. We're not going to get into the average rate of change that's on the graphic organizer, so you won't have to fill that out. I really wish we had time to get to it, but y'all, we're behind. I feel like I've said that, and then we just get further and further behind, but it's all good. So, this is where we got to yesterday. Great question. I think I actually have it in the slides. I just need to fix that. This is M1-236 or so? M1-236?
Yeah.
Okay. And we actually started to fill out a couple of details in this problem.
We've got some C.
We talked about C, right? Could this be a cubic function?
No, it was quintuple.
no.
Oh, yeah. So could this have been a cubic? No? Right? Well, and I will clarify this. Do we know it's only 5 roots? Because there could be some multiplicities in there. There could be some imaginary ones, but we know it's at least what? 5 roots. I should say no. There's at least 5 roots. Okay. We already talked about, oh no, we did not talk about what the A value is. But this is why I talked about this detail in the beginning. Anybody have a guess whether the A value is positive or negative? Okay, why do you think negative, Cameron? Lexi? Straight up, I could have sworn Cameron said that. I told you. My head is foggy right now. So if I say weird things, just be like, yo, Mr. Kenny. Yeah. Alright, so Lexi, why do you think it's a negative A value? Because it's what? It's flipped?
It starts in the negative.
But it starts in which quadrant? 3, and it ends in
4.
Notice when those odd degrees are positive, it starts in quadrant 3 and ends in quadrant 1. So A is what? Positive.
Okay, so this one's like amount of zeros it would have or whatever is going to be 1, 2, 3, 4, 5, right?
Well, that's why I said 5 roots, but notice we said at least 5 roots. We definitely know it's 5x intercepts, right? So what I was saying earlier is we know that this is at least how many roots? 2, but it could be a multiplicity of 4, right? We don't actually know. Similarly, when it goes through the x-axis, we know that it's at least an odd number of roots, but we don't know if it's 1, 2, or 3. So
that's my question, is like on the homework, it would like show a thing, and then you would have to like say which equation it matched with. And like, yeah, I can put it in the calculator and it'll show me, but doing it on my own, I couldn't tell if the little hill counted like 2 points or 1.
Whenever it touches the x-axis and then goes back away, that's an even number of
And
roots.
can you do it by the x's as well? Like if it has 4 x's, then you know it has.
Like 4 x-intercepts.
Well, I don't know, like in the equation when
She means
it's.
like that, like that's two
Yeah, like-
X's,
yeah,
so like
that,
that has a
exactly.
degree of 2.
So, one more time?
See where there's 2 x's is a degree of, like that would
Degree of
help.
2.
Yeah,
Yeah, I mean, that'd be 2 x-intercepts, x equals 3, and x equals -1.
okay, so those are the x-intercepts.
Yeah.
Okay.
Remember, and that's something to notice, if it's in factored form, those are x-intercepts. 100% for sure. But when it's a graph, we don't know if it's actually gonna be multiple roots there or not. And are we ever gonna see imaginary roots on the x-axis? No. So there could be imaginary roots. There's probably not in this case, but there could be. I will also point, we'll talk about it later actually. So is the degree of this function even or odd?
I think we said odd.
Oh, yeah, odd, because it
No,
would
yeah,
be
yeah.
that.
There we go. Look at that in behavior, right? That in behavior matches an odd in behavior. Even, they always go together. So odd. So in behavior is in opposite directions.
What if it squiggles below the x-axis and like doesn't actually touch it?
We'll get to one like that soon.
It's
Alright?
supposed to be due Friday, is that why I'm like confused?
Let's do Friday.
Okay.
So, domain of this function, guys, I'm just going through this one with y'all, and then I'm going to let you work on your own in a minute within your small groups, but what is the domain of this function? Come on.
Negative.
Yeah.
Okay, can you give us your reasoning on that?
The arrows.
The arrow, so the fact that it's going down is telling you negative infinity?
Yes.
And it kind of looks like it's like at an angle, so it's.
Well, it's going,
So, say that again, Cameron.
it's going left.
Remember, what we're talking about right now is the domain. So it's not the fact that it's going down, it's the fact that it's going down, and more importantly, to the left. Is it ever going to quit going to the left?
No.
No. Similar thing up here, is it the fact that it's going up telling us positive infinity? No, it's the fact that it's going up and to the
Right.
right. So the range,
It's the same thing.
Oh,
yeah, it's still going down and still going up. So negative infinity to infinity,
I was thinking of the, what's it called? Wait, is there a thing called a range for a?
data. It's how far the lowest data point is from the highest data point. But that's data, not functions.
Wait, what is the word that I was thinking of? Relative, that's it.
Notice with F and G, it doesn't actually ask us to identify what the relative max and min are. It's just the number. So what is the number of relative extrema?
Is that max?
I think I did forget to talk about, maybe I didn't say
Minimum
this.
and maximum.
Right. So an extrema
It's both.
is max or min, right?
It's like the-
So it's both maxima and minima together. So how many maxima and how many minima do we have?
There's 1, 2 maximum and 2 minimal, like relative.
Yeah.
4. Oh,
Oh, okay.
there's 4.
Right? 4, right? 2 relative max and 2 relative min. Why do you think they're not asking us to find exactly what those relative max and min are?
They didn't put it down. It's
They
like a
give
little
us-
weird.
If they didn't give us an equation, so is there any way to actually tell exactly what those are?
No.
No.
Well, unless we, oh, no, never mind, we can't even graph it, because there's no like.
Right,
equation.
that, and that's what Lexi was saying, is we don't have the equation, so we can't graph, we can't find exactly what they are. Number of absolute,
Two.
how about 0?
Yeah, but R, because it's infinity, so you can't.
Remember, this is going down to negative infinity, so is there any absolute minima? No.
No.
There, this is the low, and DJ, I'm assuming this is what you thought, right? But, and that is the lowest relative minimum, but do we have y values below it?
Oh, yes.
Yeah, that arrow is going to keep going down, so do I have y values below that point? Well, yes, so I don't have an absolute minimum. Same issue up here, this is the highest relative maximum, but it keeps going above that, so I don't have an actual absolute maximum. Alright, so increasing this first bit, and I always move from left to right, what's it doing to start? So negative infinity to,
29-ish?
y'all agree, 29?
I don't know. It doesn't exactly touch the
Or
line,
could, yeah, 29.
because I think it goes 10, 20, 30. I'm just looking here. Does something click in your head, because I don't understand what
You're
you're
saying
saying.
the math, so it's probably X.
Oh,
It has to go left to right, not.
Negative, like,
Negative, that's
2.5.
negative. Yeah.
What?
That's the same mistake that I told y'all everyone makes, that they try to do the y values, but remember, I'm asking for a domain interval where the graph is increasing. So where does it stop increasing is the x value, negative 2.5-ish.
But it does keep increasing up the little hill.
But what, so remember how on the bell ringer, did you identify the x or the y for where it stops increasing? So you need negative 2.5, not the 29.
Well, I'm just confused now, because on the thing when it was like, name like a point where it's, like increasing to this or whatever, we did it like to the point, increasing to the.
Yeah, to that point, but we put the x value, the domain value. It is always the domain value, so we need to keep that in mind. That is the same mistake, and please hear me, I'm not upset because that's the same mistake everyone makes. I need to put the domain interval where the function is increasing.
So would we have to, then start again, like you did from the line to the -2, but like, would you need to calculate the next increase above the line as well? Or does that just count because you already have the point?
Well, I'm stopping here at this maximum. What happens after that maximum?
Decreases.
Okay, so it starts decreasing about negative 2.5. Where does it stop decreasing? Negative 1, right? And so that's what I do, is I just go to each interval, right? I don't do all the increase and then all the decrease, I just go from left to right. After that minimum, what does it do?
Increases from -1 to.
It looks a little bit less than 0.5, so I might say 0.4, I don't know. I can't really tell unless I have an equation that I can graph on the calculator. LaShayna, what you looking for?
Which point is the 0.5?
So remember, we've already taken care of all of this, we're on this set of increase now. And so that's 0.4. LaShayna, what you looking
It's
for?
just confusing because the numbers aren't the same.
Say again.
The definition of domain.
Remember, domain is the set of all inputs, the x values. Right?
All x values you can place in.
So like, when we say domain in general, we're talking about all x values for the entire function. But when I say domain intervals where the graph is increasing, I'm talking about the x values where the function is increasing. So it's increasing from this -1 in the x to this 0.4 in the x. So like, the function is going up, that's increasing, but I'm putting the x values where it's increasing.
It's just weird.
But don't you have to be like depending because.
You're thinking about the domain for the entire function. I'm only talking about the domain interval where the function is increasing. I'll come and help y'all first when I release the small groups, okay? So after increasing, it then decreases again from 0.4 to about, I don't know, 2.1 or so. And then it increases again. Okay? So, go ahead and, I've already got that information on there. Work within your small groups on the next set of problems. Checking in with each other. I think it's number 13 is the next one. So work with each other. I'm gonna, as I said, I'll come around, check in on y'all, see how things are going. All right, let's get to work.
Okay, so